The next example is the power series of tan inverse x. You can see that tan inverse x can be related with the integral of 1 divided by 1 plus x squared. This is a standard integral result, right? And 1 over 1 plus x squared can be written like this in the series notation. And here the radius is equal to 1 because of this equation. And then in order to obtain tan inverse x, it's just a matter of integrating this term. That means integrating this power series. And we have already discussed that in a power series we can integrate term by term. So when you integrate these terms, you will obtain this, but it comes with the arbitrary constant. Okay, and to find the arbitrary constant, we just have to substitute a suitable value. And you can see that in all these terms you have a x term. So when you substitute x equals 0, all these terms will vanish, and leaving out with the arbitrary constant in the right hand side, and in the left hand side you will get 0. Then eventually you can conclude that the value of c is equal to 0. Now you have to be a bit careful when you are substituting these values, especially for the first value of this series, okay? Because sometimes this series might not contain x term in its first term in the expansion, okay? Say for example, if we have this sort of a situation, remember in the first term you have c naught without a x term. So in these sort of situations you will have the first term in the right hand side, but it was not so in this specific case, okay? So you have to be careful when you are doing the substitutions. And once you figure out that one, you can directly write down the power series representation like this without the arbitrary constant. And remember, the radius was the same as it was in the initial stage. The integration will not change the radius of convergence.